Hello. Yeah, this is not intimidating at all, the biggest room. Yeah, thanks. Thanks for that. Yeah, the last week was pretty exciting in, concerning Google Tango. Does anybody know why? Yeah, okay. So this is an Android dev conference, and I'm really glad speaking about Android here. So, yeah, so AR Core, which just was announced. So, and it's not really certain whether this is the end of Tango or if it's the beginning. If it's just, from what I've read, it might be a rebranding. So the Tango devices won't go away. You can still buy them, I guess. At least we have one, so it doesn't matter to us. But if I wanted to hold the same talk or do the same talk over again, I think I will have to rename it. So I had quite a busy weekend, as you might imagine, because I was on parental leave until Friday. So Friday morning, I read about AR Core. So with Monday doing the talk at the conference, I wasn't sure, is it possible with the AR Core? We'll see about that. Maybe it's a preview, so it might be possible in the future, no? So they said that they'll rebrand it. If you look at the feature set right now, you cannot do it. So there's another thing that might be important, and this is the visual positioning service that was announced at Google I/O this year. So, but this is closed alpha. So I tried to apply. There was some dubious Google sheet where you could supply your email address. I haven't gotten any answer yet, so I cannot tell you much about that. So I'll have to add as soon as it is released publicly. If you, been following Tango a bit, it will take some time until it's in Germany as well. So, okay. But seriously, that's me. Hi, I'm Krempel. I'm a technical consultant doing Android, indoor navigation, augmented reality frameworks, machine learning, automated speech processing, and music information retrieval. I work at Cologne Intelligence. We have like 4 units. Mobile development is the one I'm working in. We have also classical Java development, business intelligence, consulting, all that stuff. And we have customers too. So, let's get some expectations straight, because augmented reality, indoor navigation with Google Tango, I mean, the use case is clear, the technology is clear, but everything else isn't, right? So we'll talk about technical details of Tango devices. So what's different to a normal, regular Android device? What extra hardware is there? You can see there's a fisheye camera, there's an infrared light projector, there are a couple of chips for the timing between those two. Yeah, we'll talk about that. Then there's the area of indoor navigation, and we'll talk about that too. So what's different to regular Google Maps or Here Maps or Apple Maps or whatever in navigation systems, and what's different in the use case of doing that indoors, and what use cases are there for that. And of course, we'll talk about augmented reality. So this is the first notion in literature of some magical glasses that could, by which the wearer could look into another world. So I haven't read it, but it's a great quote. So what not to expect? I'll be showing some demos. Most of them are 2 years old. Or 3 years old, maybe 1 year old, depends. Don't expect too much rendering. We're not a 200 people company with 100 Unity programmers or something like that, so it's just 2 developers new to rendering. I'm not trying to sell you anything, so that's, you can expect that too. Unfortunately, for a developer conference, we're not going to be able to show too much code. No. Okay, for those of you who feel uncomfortable, here's a screenshot that make you feel familiar. So if there's need, just tell me, I'll go back to that slide for a minute. Okay. Let's talk about outdoor navigation system. I guess that piece all of you know. Yeah? Who hasn't used Google Maps? Yeah. Right. Nobody. Everybody uses it. Maybe not Google Maps, maybe Apple Maps, or Here Maps, or OpenStreetMaps. So basically, there's a lot of systems there in the market. And they're not mere maps. Maybe they started that way. You have routing, you have alternative routing, you have points of interest, restaurants, traffic information, parking spots. You can post your location and much, much more. So there are a lot of features matured into this system. But one thing hasn't changed. In order to use them, you need to know your location. I mean, you could look up your location in a map manually, but nobody would use it if it worked that way. So how does it work? With GPS, the Global Positioning Service. And this works by the intersection of spheres. You need at least 4 satellite connections to get precise results. And yeah, basically everybody is using that, and it's just normal. But it's crazy thing if you just think about how much technology is involved there. The problem with indoor navigation is that GPS does not work reliably inside buildings. That's bad. So, if we look at the task of indoor navigation, we can kind of boil it down to the task is to find a suitable route from my position to a destination inside a building. That's basic. So which parts are involved here? We have the indoor positioning system, which cannot be GPS, as I just told you. There are a couple of alternatives, and we have made some experiences with that when we developed apps for the industry of mobile. No, not mobile industry. How's it called? Automotive industry. Yeah, so cars and stuff. In order to pick my destination, I need a user interface. In order to know where are the doors, where are the walls, which paths are valid, how can I go from A to B? I need some information on the building itself, and I need some representation for that. And of course, what a suitable route is may depend on the user. Yeah? So you have different user groups having different needs. So it boils down to 4 questions. Who am I? Where do I want to go? And how do I get there, right? But stop. Do we need that? Most of the time, people get around without that. I don't need my phone telling me which route to take to the coffee maker on Monday mornings. At least most of the time I don't. But where do I actually need it? What benefit do I have by being able to do that by technology? Think about this. If you go to a mall and you're looking for a specific product, or you, as Google puts it there, have a cooperation with, I think, is it Walmart? No. Some big tech store, do-it-yourself stuff, a Baumarkt, yeah? And you're looking for that specific screw, then you should be able to find it. And this is one key feature of digital technology, that you can, if you have a lot of entities that can be represented digitally, you can search them easily, yeah? And which would take time if you do it in a manual way. So this is another thing. If you're looking for a specific book up at the shelf, or you're looking for a specific quote in a book at one shelf, this might really come in handy. We were talking about user groups. There are people that might get confused, old people, young people, blind people. And there are people who cannot walk all routes. So if you depend on a wheelchair or a handicap in any sort, it might be a good idea, if you have to travel a long way in an airport, for example, to know, okay, I'm not traveling in vain, this is the correct route. Okay, if I look at or think of an indoor navigation system, it has to be composed from some subsystems. As I already said, indoor positioning, this is one key thing that we need some kind of route calculation, and we need some kind of user interface. Let's start with the route calculation. If you think of how to solve the problem of getting from A to B in an outside car navigation, it's completely different than if you're moving inside a building. So if you're doing a route calculation in the outdoors, you can think of a network of valid paths that you have to find an optimal solution to get from A to B. Yeah? So like a maze. Yeah? You can go left, you can go right, but you cannot go straight forward through the buildings or, yeah, you get the idea. If you're thinking indoors, if I want to walk from this corner of the room into to that corner, okay, here you have all the chairs. So if the chairs were in a tier, there are a lot of routes I can take. So I can move freely, but there are obstacles in the way that block me. And these are the information that I need to calculate a good route. If I want to do this, I need some kind of information model that tells me, okay, you can go here, you cannot go there. And this is not a new problem. People have been doing this for a long time. So the classical way would be doing a room plan. Yeah? So another one, which is quite interesting, because this is from the 60s, and it's made of paper. This is how architects made up or thought of or constructed the inside of an office in the 60s. They made it out of paper. Each desk, each drawer, each chair has a small paper model, and we need something similar to this, but digital, to do an indoor navigation. User interface is another big topic. I mean, we've been talking about user interface in a couple of talks today. So, and everyone who's an Android developer knows, okay, there's a lot of details to that, and it's a complicated and serious thing. The classical way for navigation would be a map. If you think indoors, you need a room plan. So in order to do this, to maybe say, okay, I'm in this room of the Louvre. I can do this with other technology, but we'll talk about technology later. But another user interface of how it could look is something like this. This is not a real app. It's made up. It's a marketing way of, this is indoor navigation. We did that. This is more like our visual backlog that we did for our project. So this is how it should look. So if you have to go left, the blue route should just be painted on the floor. Okay, we talked a lot. Yet these are more how to tackle the problems that are specific to indoor navigation. And now we'll talk a bit about technology, and this is where Tango comes into play, right? The indoor positioning system tells me where I am. The ones that are used every day are GPS or GSM. So if you turn off the precise location updates from your phone, you get the information in which GSM cell you are. The problem is, this is really coarse. So the size of these cells ranges between a couple of 100 meters to a couple of kilometers, depending on how rural the area is. So, and how many users are in one cell. So this is not helpful for indoor navigation at all. There are solutions that you can build and that are built and that are used every day that are created using Wi-Fi or a grid of beacons. So this is just, I don't want to promote any specific vendor, it's just archetypes of equipment. So you can try to triangulate between access points or measure the strength of Wi-Fi signals. Or you can triangulate between grids of small devices that run on battery and emit Bluetooth waves. Yeah? So, and basically, these Bluetooth beacons, we had some experience with that, and that's why I came to developing a Tango app in the first place. So what you do there is when you have a room like this, you would install maybe 100 small battery-driven Bluetooth devices and put them at the ceiling. And after that, when you put on your Bluetooth radio, these beacons, what they're doing is they emit, I am here, I am here, I am here. The German word for beacon is Leuchtturm, yeah? Leuchtfeuer. So it just emits an ID, a unique ID consisting of 3 values, so you can keep them apart. And the precision of such a system really depends on how many beacons you put in there. So if you want to have meter-grade precision, you maybe need, depending on how good your beacons are and how good your algorithms are, you need maybe each 2 meters you need a beacon. And this creates effort, especially if you do it in large places, and you will not do an indoor navigation in small places because it doesn't make sense. So we have some project experiences with that. Let me just look up the numbers. I think the one project we did, it was more like a zone-based location. So you could say, okay, you're in this room, yeah, or you're in that area. And this was 23,000 square meters, and we had over 100 beacons for that. And the other project we did was 40,000 square meters, and it was nearly 1,000 beacons. So if you think of the effort that you have by maintaining, setting up such a beacon grid, it's like changing the light bulbs on this bridge every couple of years and writing down a number into a backend for each one of them and putting them on a map where they are. So this is crazy. Yeah? It's not maintainable. And it's expensive too, because each beacon costs about maybe 20 to 30 bucks. So this is, one thing I forgot to mention. So what's the rate that such beacons emit position updates? 2 times a second. That's 2 times a second is the most, the fastest one that you can choose for the ones I work with. And this drains battery, yeah? So if you push up the update rate, battery will drain more quickly. Okay, now this is why we thought Google Tango is a real cool thing, because just to put it forward, you get position updates 100 times a second, and they're centimeter grade precision. So it's different, completely different thing. You can do different things because we tried to do an AR interface based on beacons. So, and if you get a position update that jumps between 2 and 3 meters 2 times a second, it doesn't look right. No matter how good your algorithms are, it doesn't. Okay, so what's the difference? What about Tango? Who's into Tango? Who has read something about it? Yeah, a couple of you. Okay, but that means I have to explain a bit more in detail. So they are based on Android. This is the second device. There are 4 devices. 2 of them are developer devices, which are only for developers. 2 of them are available on the consumer market. This is the Yellowstone tablet, and it has extra cameras. A fisheye camera and an infrared projector. And what the infrared projector does, it emits structured light, and the infrared camera records that. And by that, it can collect measurements of distance. So you get like pixels, not pixel. They're not pixel. I think I just forgot the term. Doesn't matter. So you get 300 times 200 pixels of depth measurement. So how far is the wall away? Is it 5 meters, 3 meters 60, or just 80 centimeters? Something like this. A point cloud. So let's talk a bit about devices. I'm really going fast because there are a lot of slides for not so much time. This was the first one, Peanut Phone. This is the Yellowstone tablet, the one that you just saw the drawing of. And these are the consumer devices. This is Lenovo Fab 2 Pro. It's a big, big phablet. It's like 7-inch, and it's more like a brick. You can, if you get attacked at night, it's really helpful. And this is the new one, this Asus Zenfone AR, and it's really cool because it also can do Daydream. So this was released a couple of weeks ago, And yeah, if you want to, I have some problems with Visio, so I wanted to show some things, but it doesn't work too good. So I have all these devices with me, so if anybody wants to see a real demo and wants to try it out, just let me know after the talk. Okay, so what are the key features? What can Tango, it's not only the sensors or the additional hardware, it's also a software library. It's an SDK that you can use. Yeah? So you have three main features: motion tracking, that tracks your motion through space. You have area learning. So Tango tries in a way to imitate the way that humans perceive the world. Yeah? So even if you close your eyes and turn around 5 times, and you open your eyes, you know in which direction you're facing. And that is because from the details in your environment, your brain can recreate a feeling, a sense of position. Yeah? And this is done visually. And that's the way area learning can re-recognize poses in space where it has been in a training phase. So we will get to the details later. Depth perception is basically based on the sensor, the depth sensor. So you can scan objects. Yeah, you can do a 3D scan maybe of this object and have it as a mesh that you can process maybe in Unity or in Blender or whatever tool of your choice, and you can work with it. Let's talk a bit about motion tracking. So in order to describe the position of a device in space fully, you need 6 degrees. You have 6 degrees of freedom. You have X, Y, Z coordinates, the translation in space to some reference point. And you have roll, pitch, and yaw, which are the rotation vectors. Yeah? So if you have these 6 values and you know where the origin of your coordinate system is, you can describe this is the position of the device. So most of this is done by sensor fusion. Who knows what that is? It's a gyro. So it's an inertial measurement unit, IMU. And this one is, this is from a Saturn rocket. I think it's huge and heavy. And this one is the miniaturized version that most of you have in your phone. Well, I think maybe all of you. Just to remind you, these kind of sensors were first used in air flight, so you needed to describe the position of an airplane in space. So that's why these axis names, rotation names, have these names: yaw, roll, and pitch. Okay, this is not the only thing. These are not the only information that are used. So we also need, by having different positions in space, there's an effect that in the image stream, if you say so, in the video stream, the pixels move along. These are so-called wiggle images. They show rooms out of 2 perspectives for each eye, but the idea is that Okay, I'm there. The problem is, water isn't completely still. There's wind, there's current, and stuff like that. So your correct position and your reckoned position are not the same. So the difference could be called drift. So this is another Tango application. So when you use area learning, you walk around and you train your device, and this creates training data. So what you see here, this is a Congress Center in Cologne where we did some kind of talk too, and you see these frustrums. These are the positions that were used during the training run, so we went forth and back again. And if you see the green points, these are the details that Tango uses to re-recognize your position. So, and even if there's areas like these where you don't have so many details, what happens then is we're on motion tracking. Here's the time since the last success, and we will get in a region, because it's infrared light, sunlight really interferes with the sensor. If you turn around the corner, then there will be a lot of sunlight, and Tango will lose the tracking. But it doesn't matter, because for a couple of seconds, motion tracking is stable enough. Yeah? So you should lose it now. You see on the left there's windows, and you see here the distance that you traveled and the time since the last successful re-recognition. So this is how the tracking works, and it works really, really well. Okay, so what we did is, we did some prototypes. Yeah, so we went there, and this is one of the first prototypes we did. This is maps navigation. Yeah, so you see the floor plan, but you see the arrow move. It's really smooth, and it's way better than all the things that we did before with that in that use case. Okay, let's talk a bit about these training data. It's called ADF, area description files, and they grow up to like 50 megabytes, even more. Depends on the size of the building you've trained. From the Tango SDK, you can load them, you can store them, you can export them, you can import them, so you could even store them in the backend. And this is actually what, in my opinion, the visual positioning service will do. It will just supply the cloud infrastructure for these kind of files and this information, so you can have this everywhere where you've trained. Okay, last core feature would be depth perception. And as I said, we have these additional hardware. So we have the camera, and we have the infrared beamer, and you have structured light, and you have measurement points. So, and this renders some kind of point cloud. We can try whether visual likes us, but I wouldn't be too optimistic about that, because it didn't work all the time. No, okay. I will show you a video so we get a better impression. This is kind of a fallback. Oh, wait. So this is another real old recording. So you have a top view, bird view, on our building information model. These are all these red and blue objects. And you see these are the points of the point cloud. I will try to restart that. So, and we're looking at to the floor. That's why you have these points. So, these you can just paint them to your OpenGL world. And one thing that you can do, the one problem that augmented reality has, it's just an overlay. And this doesn't matter if it's ARKit or if it's Vuforia or Metaio or whatever SDK you're using. There are a couple of those. You just paint on top of it. Yeah? So if there's a chair in front of the virtual beast you're painting, the beast will be before the chair and the immersion is gone. Yeah? And this is something. We did some kind of experiment, but this can be changed by Tango as well. So the virtual beasts you're fighting will hide behind rocks and trees and whatever. Yeah. So this is mainly the video why I was talking about don't expect too much of our rendering skills. This looks a bit like Monkey Island, but it's But this is due to the low resolution of the depth sensor in the Yellowstone device. They improved that, and it's getting better. Okay, some lessons learned from developing for Tango. Refresh your 3D math. Who can tell me whether a quaternion, how to deal with quaternions and to calculate distances in 3D and rotations? It's nice. Yeah, and it's complicated too, especially if you're doing it with the Java API. There are plugins for Unity as well, so this is more like a game-like thing than you just steering the virtual camera. But if you do it with Java, it can get pretty complex. Okay, some weaknesses of the system. If you, in a white room with no details at all, Tango won't find a thing, right? So you need details. And it really depends on lighting conditions. So if you turn off the light or it's another time of day, you have to retrain. This can be a problem. Also, environments tend to change more often than not. And this might confuse Tango. Although we experienced that it actually keeps on working pretty good because a lot of details are in the structure. It's mostly enough to still estimate the position. And as it imitates human vision, there are situations that really can confuse us. Yeah? I get confused all the time. This is our office. And another thing is, as I said, sunlight really, and mirrors, reflective things, and garlic don't work. Okay, so this is actually what we built with that, if it starts. This is the last thing. We've been going to conferences and doing indoor navigation for them. It takes maybe 1 day to set up, and then you can see what we've been doing. This is another conference. Just don't look at which it is. No, it's at Cologne, with like 3 weeks ago, I guess. No. So, and this is the current state of our prototype or solution or whatever you want to call it. So you can just pick your destination. This is our booth up there. And as you can see, well, we didn't include any occlusion yet. So because it looks like Monkey Island, if you tend to show it to somebody who says, you're coming from the 1990s. So, yeah. Okay, I think you get the idea. It's not perfect. One problem is that you have to model, like the building information model, to match the real world. And this is not so easy, or tends to be not so easy. Yeah. And of course, not all obstacles that are in the way are static. Yeah, the people that are moving there, the route will just be painted through them. Okay. Okay, I think you get the idea. There have been other experiments like that, and there's even a Google Plus community for the developers that are doing stuff like that. Okay. This, yeah, it really got me on Thursday. So I thought I cannot do a talk about augmented reality and Android without just talking about AR Core a bit. So this is how it looks like if we try it out. And I just want to talk, what are the differences? Just think about it. I had like 3 days time, so don't expect too much. But I can give a quick overview. What are the differences to Tango? Yeah. So first thing is, you can do AR Core for the web, and you can do it for Unreal too. And you don't have a C API like you have for Tango devices. Rest, for Unity and Java, they both have APIs. AR Core has 3 main features as well, and some of them are pretty similar to what Tango can do. So basically, this is what they said in these interviews or in the articles that were published to AR Core, that they used the information or the knowledge they gathered from Tango to improve or to create AR Core. So first is motion tracking. This is pretty similar because every Android device, or most new devices, have an IMU and have an accelerometer, and so it works. Instead of area learning, AR core is something called environmental understanding. And though these are a bit similar, there are some differences, and I will talk about that in a minute. And other things, okay, depth perception, you cannot really do this good without the additional hardware. One thing which is new is the light estimation, and this really helps to improve the immersion, because the objects are lighted in the right way, and it looks pretty realistic then. Okay, so basically, motion tracking is the common thing. Area learning and environment understanding are similar, but a bit different, and these two are different. So first thing, you can store area learning files. From what I've seen in the API, you cannot store the results from the environment understanding, but maybe this will change in the future, so we'll see. It's still a preview version, so there might be stuff added. The other thing is, when you're using area learning, you have measurements of a sensor. When the environment understanding detects planes, like the table that you're putting your virtual objects on, it's an estimation. It's based on a mathematical model, and it can be wrong. The complexity of the objects that you can detect differs too. So if you have environment understanding in AR core, it's just planes. Yeah? It's said to be doing or detecting walls too. I haven't seen that in the demo yet, but you cannot scan complex objects like you can with Tango. And another thing, which I'm not really certain of because I haven't had enough time to really test it, we tested these area learning capabilities of Tango on really huge buildings, yeah? Something like here. These, so if you think of an indoor navigation at a dimension like droidCon, which are pretty huge spaces, it works. And the environment understanding, I think, in my opinion, it's more intended to be working for tabletop or flat-sized environments, but it could prove me wrong. And we're still at a preview level, right? So, what now? No more Google Tango. So, the decision to publish ARKit makes totally sense in my eyes. So the problems that we had while trying to acquire some projects with the cool prototype that you saw, it's always, yeah, that's cool, let's do it. So yeah, but there are only 2 devices for sale, and people have to buy them. Never call us again. No, it's not like that, but it's pretty tough. So and of course, they don't want to build another ecosystem of people using Tango devices, and so this is not realistic. So it's the logical step to do it like that. And for most use cases, it works. And if they manage to do it without additional sensors, even better. And we will see what will happen in the future. If I want to cite The Verge, so that means Tango, not technically dead. Google will supposedly keep pushing for new and better cameras based on Tango tech, like a depth sensor, but these would be added to phones as an element of AR core, not as a discrete feature. Yeah? So I can really recommend this article. So this is, I think, the most information that you can get about AR core at the moment. The real interesting thing is if Google puts itself in the center and supplies these ADF files that maybe were recorded with Tango devices or something, or 3D scanners, and you can use indoor navigation on every phone without additional hardware, this is really cool. And if that works, then we'll see a lot of indoor navigation apps. And yeah, we'll see what the future brings. I think it's exciting, especially as there are coming new standalone AR devices, and we'll see in fall what's happening. So thank you for listening.
Thank you, Till. Are there questions? Questions to Till on his... Yes, please.
Do you have the AR core demo with you?
Yeah.
Cool.
Hi. So I have a question regarding battery consumption.
Yeah.
What was the battery consumption on the Tango device when you used it in the wild? Like, was it visibly more
Yeah.
power hungry?
Yes, for sure. It depends. It depends which features are active. Yeah. But if you turn on the depth scanner, yeah, of course, it's like having a headlight, the flashlight on. Huh? And especially, this got better over time. And this is, I think, where they invested a lot of time. Yeah? So the first devices, they were like, had a fat battery and it was drained in maybe half an hour. But if you look at the consumer devices, it's really better.
Okay, cool.
Yeah.
Was it also like the same for AR core, or you didn't get a chance? It's still
Maybe give me a call in half a year, then I can tell you more.
Thanks a lot.
Sure.
That was it?
Okay.
I'm sorry.
Is it good?
Till, thanks
Okay,
a lot.
what does your company say about the AR core? Are
sorry.
they like, oh, we got to switch now, or we going to stay with Tango and let's see what happens?
Well, a good thing is that this is not our core business, so we're doing application development, and I was able to do this as a new technology lab project. So we'll wait and see. Just at this moment, it's a lot of speculation, and we'll see what ARKit does. If it's just rebranding Tango, then nothing's changing. But we'll see about that. Still, Tango devices, they're out there. You can use them. You can buy them. So it doesn't hinder us from continuing to do some stuff.
Thanks again, Till. That was
Thanks
it.
for having us.
Thanks a lot.